Exponential equations. You will find this on page 186 in the Namibian Ordinary Level Mathematics textbook, Y equals mx plus c to success. Exponential equations. Before you try to solve exponential equations, you must be quite comfortable using the laws and definitions of indices, exponents. An exponential equation is simply an equation in which a variable appears in the index, in the exponent. Okay, so on top. To solve exponential equations, you need to have equations with comparable terms on either side of the equal sign, so that you can set the two powers equal to each other and solve the resulting equation. Let's show you an example. Example 10. Solve for x. Can you see? The basis is 7, the basis is 7. So then you can go and you can almost say just equate this and say x is equal to 3. And the answer will be 3. And if you substitute it there, you will get exactly the same on both sides. In this case, it's a 4 and it's a 8. But you can first write it in prime factors. Okay, so if you 4, so that will be 2 to the power 2. 8 will be 2 to the power 3. Now the bases are the same, and now you're going to say, okay, if that is the same, one term equals one term, then I can say 2x equals 3. And then I divide by 2, and that will be my final answer. Okay, try now 10. I want you to stop the video, and I want you to do number A as well as number C. You can continue the video as soon as you are finished. Okay, let's start. Let's start with number A. So it's 2 to the power x equals 2 to the power of 5. So in this case, the 2 is equal to, the bases are the same, so therefore x will be equal to 5. Let's do the next one, number C. 4 to the power x equals 64. Now, if you write it as prime factors, so let's say 4, can you still remember? Take your prime numbers, 2 can go in 2, 2 can go in 1. 64, 2 can go in 32, 2 can go in 16, 2 can go in 8, 2 can go in 4, 2 can go in 2, and 2 can go in 1. 1, 2, 3, 4, 5, 6. So that's 2 to the power 6, and that's 2 to the power 2. So if I'm going to, I'm going to say 2 to the power 2, and it's that x, and this is going to be 2 to the power 6. So it's actually 2 to the power 2x equals 2 to the power 6. So therefore, 2x is equal to 6. I divide 2, and the value of x will be equal to 3. Okay. Okay, let's look at another example. Solve the following equations. This one, this one, this one. Now in this case, there's a 5 and there's a 1. But I can write this to the power of 0. Anything to the power of 0 is equal to 1. So I can make it 5 to the power 0. So therefore, x will be 0. In this case, I write it prime factors and then bring it up. So if it's 2 to the power 2, if I bring it up, it will become negative 2. And now it's 2, 2, and now I can say 3x equals negative 2. I divide 3, and the value of x is negative 2 over 3. And then this one, I first make it a vulgar fraction, then simplify it. Okay. Say divide by 125,000, and that's 8. So it's 1 over 8. Then I write it in my prime, 2 to the power 3, bring it up. So therefore, x is equal to negative 3. Okay, I want you to do, okay, let's see, stop the video and do number A. Okay, I want you also to do for me number D. And then number 2A. You can continue the video as soon as you are finished. Just going to make space here. And I'm going to move this one up. So this is 1a. So this is 10 to the power of x is equal to 1 over 100. Okay, now if it's 10, then don't write it in prime factors, always. I want to show you here. If it's 10, or it's 100, or it's 1,000, or it's 10,000, then it's better to say this is 10 to the power 1. This is 10 to the power 2. This is 10 to the power 3. This will be 10 to the power 4. Can you see? So how many zeros? It will be that. 2 zeros 2, 3 zeros 3, 4 zeros 4, and you can test it on your calculator. So if I come to this one, it will be 10 to the power x. First do, and that's 10 to the power 2, but then bring it up. So then it's 10 to the power x equals 10 to the power negative 2. So therefore, x is equal to negative 2. That's my final answer. Okay, then number D. So it's 1 over 4 to the power negative x equals 1 over 2. Okay, so so this is going to be 1 over 2 to the power 2 negative x equals 1 over 2. Okay, if I bring it up a little bit, okay, let's just do it like this. So it's going to be 1 over 2 to the power negative 2x equals 1 over 2. So if I bring it up, so it will be positive 2x, because that sign change if you bring it up, and this one will be negative, from a negative to a positive, from a positive to a negative, from a negative to a positive. So therefore, let's just move it up still a little bit. So therefore, 2x is equal to negative 1. And if I divide 2, the value of x will be equal to negative a half. Okay, and that's your final answer. Let's look at the next example. So in this example, solve for y, okay, is equal 1. Now in this case, there's not only 1 on this side, there's 2. Although there's a multiplication, it's one term, but it's almost like it's separated. So first, also make your bases the same. First get it just a single base, not two bases, 1. So just follow your rules of indices. If it's multiply, I add the exponents. And now you can say, as soon as it's 1 equals 1 base, you can equate the top. And then you can divide 3, and that's your final answer. Okay. Again, I want you to stop the video. And I want you to do 12, number 12. You can just do number A, and you can do number C. You can continue the video as soon as you are finished. Okay, let's start with number A. So it's 8y plus 1 multiply 4y minus 1 is equal to 16. Okay, let's just do the prime factors. So it's 2 to the power 3 y plus 1 multiply 2 to the power 2 y minus 1 is equal to 2 to the power 4. So then this is going to give me 2 to the power, just multiply it in, so it's 3y plus 3 multiply 2y minus 2 equals 2 to the power of 4. So it's 2, and then it's 3y plus 3 plus 2y minus 2 equals 2. Let's just get that correct. 2 to the power of 4. Okay, let's just bring this down. So then this will be 3y plus 3 plus 2y minus 2 is equal to 4. So 3y plus 2y is 5y plus 1 is equal to 4. So 5y is equal to 4 minus 1. So 5y is equal to 3. Okay. And then I'm going to continue on, and then I'm just going to divide 5, and I divide 5, and the value of y is going to be 3 over 5. So therefore y equals 3 over 5. That's my final. Okay, let's do the next one. I'm just going to clean that one. Okay, then number C, and 9y minus 1 multiply 3y plus 1 is equal to 1 over 27. So it's 3 to the power 2 y minus 1 multiply 3y plus 1 equals 1, 3 to the power of 3. So it's 3 2y, let's just get the pen correct, 2y minus 2 multiply 3y plus 1 equals 3 to the power of negative 3. So it's 3 2y minus 2 plus y plus 1 equals 3 to the power of negative 3. So 2y, so therefore 2y minus 2 plus y plus 1 is equal to negative 3. So 2y plus, so it's 3y minus 1 is equal to negative 3. So 3y is equal to negative 3 plus 1. So 3y is negative 2. I divide 3. So the value of y will be negative 2 over 3. Y equals negative 2 over 3. And that's the final answer. Okay, let's look at another example. Okay, so in this case, let's look at that final one. Solve for x, and again, okay, now be careful. This is more complicated because now it is definitely two terms. There's a negative in. So this is very important. So there is not a multiplication or a division sign between the terms. So you cannot use the multiplication or the division laws. So what we are going to do is we are going to call it splitting. So splitting involves that we are going to take, it's almost like, say for example, you are having this and you have to reverse up. Okay, so in this case, instead to get that, I'm going to make it 5 to the power x and 5 to the power 2. 5x, 5 negative, so I give everyone its own base. Then I take 5 to the power x out as a common factor, and then this is left. And then 25 minus 1 over 5. So I get this, I divide, and that is, then I get this, and now I take it again to prime factors, and therefore the value of x is 3. Now, that's a bit complicated. The same here. First do the splitting. It's just reversing back so that every index is having its own base. Okay. And now, in this case, split the terms, do the reverse of multiplication rule. Now it's a trinomial. Okay, now if you see as the trinomial, and let me just show you here. Say for example this 3 to the power 2x, 3 to the power x. It's almost like that and that. So it's almost like it is k squared and k and without a k. So there's the 3, the negative 4, and the 1. So do your rules. Is it group A or B? Think back of trinomials. Go back to that section if you cannot recall it, chapter 3. Then it's in group A, so it's because there's a positive. So actually, can I just show you? Focus on that numbers. So it's going to be 3 and 1 and 1 and 1. So 1 plus 3, it's going to be 4, and the signs is going to be minus, minus. And then it's going to be 3 to the power x, 3 to the power x. Okay, and that's what I got there. And then I'm just going to simplify both brackets, so put that equals 0, and I divide that, and then I get my two values. Wow, that was complicated. Okay, let's do an example. Again, I want you to stop the video, take your time, it's a bit more complicated. Okay, let's just move it up a little bit. I want you just to do number A. Try now 13, just number A. Again, you can continue the video as soon as you are finished. Okay, so if I start with number A, so it's 3 to the power of x minus 3 to the power x minus 2, and that's 24. Now, first break, because it's a negative. You cannot add the exponents. It's not a multiply. So I'm just going to split. Now, splitting is just that you give every index its own base. Because if you work up, you would have kept one base, x minus 2, or x plus minus 2. Okay, and then it's 24. And then as soon as you did that, you're going to take out a common factor. Now, what is my common factor? It's 3 to the power x, and it's 1 minus 3, because there's the term, as soon as you divide, it's 1 minus 3 to the power negative 2. So that is going to be 3 to the power x. So this is 1 minus, and it's 1 over 3 to the power 2, so 1 over 9, it's 24. So it's 3 to the power x. Now it's 1 minus 1 over 9. So if I'm going to do that, it's going to be 8 over 9. Okay, I'll just show you here on the side, because it was 1 minus 1 over 9. And that's going to give you that 8 over 9, the one I got there. Okay. And then it's equal to 24. And then I divide 8 over 9, and I divide 8 over 9. So 3 to the power x equals 24 over 1 multiplying 9 over 8. Okay, so it's 3 to the power x. So it's going to be, this is going in 1. This is going to be 3, and 3 times 9 is going to be 27. And now I'm going to have 3 to the power x equals 3 to the power 3. And so therefore, my value of x is equal to 3. And that will be my final answer. In the next video, we will look at equations with rational indices.